All right, at this point I'm recording. Hopefully it'll be up there. Well, if it's up there, but then you know that what happened already. Anyway, where were we? So the index is going to be at most what? The size, the list's size, not the array's size. So L dot get size. Then it will be safe to do this stuff. Oh, and then there's no and in. Again, too much Python lately. I'm confusing myself. In Python, you don't use the ampersand, you use and. Right? And then I can print it out. Right? It's not going to print anything out here because, of course, it's beyond that size, and so it's not going to work. Right? Now, should I have to do that outside of the class? No. Error checking sounds like a list kind of thing. It sounds like a list responsibility. So where does that responsibility lie? In the class. If the index is greater than, now what I'm going to do is I'm going to switch around the safety. The conditions I had before, that was when it was safe to do it. When it's not safe to do it is when it's less than 0, or right, the index is greater than, and I'm going to switch the sides here. The index is greater than or equal to the size. Why greater than or equal to? And then this, dot get size. Why greater than or equal to? If there are 10 elements in there, and I ask for the index 10, that's the 11th element, right? So if it's equal to 10, if it's equal to the size, I'm one beyond because of 0 indexing, okay? What should I do in that case? You asked for something that doesn't exist. I'll throw an exception. Or I could return, one option is I could return null, right? Another option would be system.out.exit. Kill the entire program. Not out, sorry. There is an exit though. Should I kill the entire program if you ask for something that doesn't exist? Imagine if your array list implementation did that. Really frustrating, right? So what should I do? Throw a new illegal argument exception. I could throw a new, like an index out of bounds exception, but I'm going to go ahead and throw an illegal argument exception. Index plus index plus, and then the message will say is out of bounds. Okay. Now let's come back over here to the demo, and let's try that again. And I'll go ahead and keep it at index here. All right. This is going to fail. Oh, did I get rid of my index is equal to 15? Sorry. There we go. And that should fail with an appropriate error message. Index 15 is out of bounds. Now it's not some mysterious null. What are you talking about? My list is not null. I asked for something that I shouldn't have. I'm getting a more sensible error message back. I have no leaky abstraction here at all now. Right? I'm not going to get an index out of bounds exception from the array itself, etc. I'm going to get a sensible error message, right, that gives me some information as to what happened. Index negative 15 is out of bounds. Okay. All right. But let's do a little bit of regression testing here. Will it still work if we ask for the 11th element at index 10? Yes. Okay. All right. Good. Anything else? Well, if we can get an element at a particular index, maybe we would want to add an element at a particular index. So if I've got 10 through 50 over here, and I've got 60 through 100 over here, I want to put something smack dab in the middle. Right? Am I going to be able to do that with an array? Not directly. What will I have to do? I could take two arrays, but ultimately I'm going to have to, meld them back together, right? I need to make room. So, you guys go ahead and move down. Now I've got room to put you there. Right? So let's go ahead and put that in there as well. Public void add at index. Right? And we're going to take two things this time, the integer that you want to add and the index at which you want to add it. Index, int, index. There we go. What are valid indexes in this case? Can you add at index 0 if there's nothing in there? Yeah, what are you doing? You're just adding something to the beginning, right? If there are 5 things in there, I can add something at index 0 by shifting everything down, right? I could add it at 1, shifting these 4 elements down, and now I've got 10, 42, and then the rest of this stuff. Right? So 0, 1, 2, 3, 4 seem all valid to me, right? That you want to add it at 4, then this guy moves down so that you can put it right there. Right? And this is why I'm lamenting that I can't use my iPad now, because I would have drawn this out instead of using my fingers. Right? So 0, 1, 2, 3, 4, that seems valid. But what about 6? Or sorry, 5. Index 5. Why not? That's just adding it to the end, right? Okay. So let's go ahead and make sure that we are checking those error bounds. If the index is, should it be negative? No. Or the index is strictly greater than this size. Then we'll throw an index out of bounds, an illegal argument exception here. Same error message. Don't need to get fancy. Right? That index is out of bounds. So the only way that it's different is that less than or equal to here. If the index is strictly greater than the size is fine. We can put it there for you. Okay. It's going to look very, very similar over here, right? That if it's full, then I will go ahead and make more room, right? So copy, paste. Sound like a good practice? Nope. So anytime you have code at multiple places, what is that screaming out to you? Public void increase capacity, right? Right? And the way that I'm going to increase capacity is by simply taking everything inside here. There we go. So creating a new array, copying things over, creating another new array. I'm going to simplify this now and show you a trick. If you regularly RTM, read the documentation, right? Read the manual, then you'll find that there are things to do this for you already. Arrays dot copy of, right? I want to copy this dot array, and I want to give it a new length. The new length will be this dot array dot length plus 10. Right? What it does is it makes a copy of it, copies everything over for you, and then if the new size is larger, it'll actually expand it out. It'll create something that's new and larger, copying everything over, and I believe filling it up with zeros at the end. If you want to copy an array, but you only want to copy the first 5 elements, your new size could be 5, right? And it'll copy over the first 5 elements into a new array. This dot array is equal to that. Very, very convenient, right? So instead of doing it the hard way, we'll do it the easy way, having read the manual and finding out that that works, right? This dot increase capacity. Okay. In fact, now I'm going to go ahead and replace all of this down here as well, right? If it's full, then we can go ahead and increase capacity. There is a problem with this design, though. Over here in the demonstration class, let me go and take my list and then increase capacity. Should the outside world be allowed to do that? Probably not, right? That's something that's internal to the class, right? That would be a leaky abstraction. In fact, it would be even worse if we said, you take care of increasing the capacity. You call that method over there to increase capacity, then you can put it in, right? Oh, you didn't increase capacity, that's on you? That doesn't make any sense, right? We made this list, my list, we designed it so that it takes care of all those details for us. That would be a leaky abstraction, bad abstraction. So we don't want to leak that information out, So what should we do and not allow the outside world access to this thing? Make it private. Right? We can still do it, but they can't anymore. Over here in demonstration, now you can't do it anymore. Excellent. Good encapsulation, protection of your variables, protection of your methods. Right? You can't increase capacity. That's a list thing. I'm a list. I take care of it. Right? Good. So we've definitely got room for it. For example, if it was full and we wanted to put something smack dab in the middle or at the beginning, right, and it was full, now we've increased the capacity, but everything is still where it is. Right? What do we need to do? We need to shift those things down. Right? So shift elements down to make room. Right? Dot, dot, dot. Now if I want to put something at index 0, let's just take that there are 5 elements in there now. I want to put something at index 0. That means I'm going to start at 0 and shift this one over here, shift this one over here, shift this one over here, shift this one over here. That sounds complicated because I'm going to have to take this and put this into a temporary variable so that I'm going to have to take the next one, put it in a temporary variable, shift this over. Now I can put my temporary variable back in, and at this point I've crossed all my fingers and I have no idea what I'm doing anymore. Right? So here are my 5 elements. I want to put it at index 0. What if I started at the end? Move this one over, move this one over, move this one over. Do I have to worry about any temporary variables at all? Nope. Move it over, and now everything's been shifted and I can put it right where it belongs. So I'm going to start at the end. For int I equals, where do I start at the end? I want to take this element here and I want to move it over 1. I want to take array sub, say, I plus 1 is equal to array sub I. Right? Plus 1 is over here. I'm going to take this element and put it over there. Plus 1 is equal to this one over here. This one is still here. It's just that I've copied it over. Right? But then next time I do this, I copy this one over. I copy this one over. So where should I start? If I have 5 elements in there, where should I start this process? At index 5? 4, to shift it over to 5, right? So that corresponds to this dot size. Right? When do I want to stop? Question mark. How do I proceed? I want to go down, so I minus minus, right? Now back to the question mark here, right? When do I stop? If you want to insert it at 0, 1, 2, right? Shift, 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 done. Do I shift any of this stuff? No, I want to put it right here. Index, so while I is greater than or equal to index. You said plus 1, which would be right if you went strictly greater than, right? But I'm just going to go, I'm going to make it simpler and say, go all the way down to the index that you want to insert it, because you need to move index over to index plus 1. Right? And now you've moved everything over, and now you can go ahead and put it where it belongs. So put x at index. So array dot index is equal to x. This dot, I should have this dot everywhere. There's only one ARR, so Java's happy with that, but it is best practice to go ahead and use the this keyword, even when it's not necessary. Excellent. Let's come back over here to demo, make sure it still works. Yep. Let's go ahead and cut this down to 10. And 5. Right. Nope, what's wrong? Oh, yeah, well, that's at index 5. Oh, I meant 100. Thank you. There we go. I want 10 to 100 in there. All right, let's go ahead and test this out. What are some cases that I should test out? What are some corner cases? Corner cases would literally, in this case, be what happens when you add it at index 0? What happens when you add it at the end? Then what happens when you add it somewhere in the middle? Right? So let's go ahead and l.add at index. We'll add 42 to make it visually completely different. And we'll add it at index 0. And then let's see if this works. What should I expect? 42 and then 10 through 100. Oh, sorry, not X. The list. 42, 10 to 90? Uh-oh. Failed. What happened? There are 10 elements in there. You put one in there. How many elements are there now in there? Remember, we just shifted stuff down, so if there are 10 to 100, and 42 is right at the beginning now, how many elements are in there? I don't have enough fingers. 11. Did we account for that? This dot size plus plus. Okay. Come back over here. Oh, okay, that was the problem. Let's test another corner case. Another corner case would be where if we've got 10 elements in there, we want to add it at index 10 at the end. Right. There. 10 to 100, 42 at the end. What if we should test another corner case or aberrant case or edge case, if you want to call them that, would be a negative value like we did before. You can't add that at index 0 or at index negative 10, exception. You can't add it at index 100 because there aren't 100 elements in there, right? It's out of bounds. What's another thing that we should test? Adding it somewhere smack dab in the middle, right? I is equal to 5, right? What would we expect here? 10, 20, 30, 40, 50, well, here. 0, 1, 2, 3, 4, 5. So I would expect 10 through, 0, 1, 2, 3, 4, 5. 10 through 50, then 42, then the rest of them. Let's try it out. Yay, it works. Right? Now this is ad hoc testing. This is me just throwing values out there, inspecting it. Good, 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 good. All right, if we start making changes to this design, if we start making changes to this list implementation, what am I going to end up having to do? Test it all again. Type stuff in, look at it manually, type stuff in, look at it manually. What should I be doing instead? Probably designing these things in an automated way using unit testing frameworks like JUnit. And when you get to Lab 11, we've already provided that for you, but you should also be designing these things to be automated, basically. You can put it into a list. Try to add 50 things, then try to interleave 50 other things, right? And that would take me a long time to type out and also to verify visually. But I can automate. That's why we have computers. We automate them. Computers can be automated to test themselves, right? And that's what you should be doing. This is just ad hoc testing, though. I'm pretty sure that it works so far. Okay. All right. So, way to remove things? A way to modify things? Way to remove things. What would that look like? I'm not going to do it, but what would that look like? Remove element at index, say. It would shift stuff back down. In other words, it would just be the reverse of this. You'd have to do index checking. You would not have to do capacity checking because if you're taking something out, you're automatically making it smaller. You're taking this guy out and you're just making it smaller. You do have to make sure that the size is decremented after you've shifted everything down. When you shift things down, you start at the index that you want to start at, and then you can shift, pull this one over, pull this one over, pull this one over. You don't have to do something fancy like starting at the end. Right? Okay. This is nice for our first iteration. What is this list good for, though, my list? Just integers, right? What if I wanted my list, my other list, or names, let's say, is equal to new my list, and then names.add I'll just add to end Chris. All right? Joe. Jane. Why doesn't it work? This is not a list for whatever. This is a list only for integers. All right? So, object-oriented programming principles. So far, we have good encapsulation, the protection of our list. So far, we have good abstraction. You don't have to worry about any of the details. I take care of it for you. You give me the thing that you want to put in, and I will expand, contract, do whatever you want. Or do whatever I need to do to get it in the list. We so far yet don't have good polymorphism. Remember, polymorphism is where you can use the same chunk of code, same variable, same method, or same class for multiple different types at different points in your program. Right? So remember the syntax. I will parameterize this list, right? Or this class, I should say. When I've parameterized it, now what I can do is instead of making these integers or strings or doubles, what could I do? Make it an array of t's. What is it, an array of doubles? It can be. Is it an array of strings? Can be. Right? All you need to do is parameterize it, and it's an array. It's a list of whatever you want it to be. Okay. Now we are going to have to fix a few things around here. First thing is that this is no longer correct because I don't want an integer. I don't want an array of integers. I want an array of t's. Sorry, capital T's. That still won't compile. And the reason is that polymorphism, making things generic, this parameterization, was added in later versions of Java. I think Java 5 and beyond. Java didn't start out that way. So as part of a compromise, you know, making sure that it was backwards compatible, they had to implement this and support this some way. Unfortunately, the Java virtual machine doesn't know what you want. It doesn't know that if you want an array of doubles. It doesn't know if you want an array of integers. It doesn't know if you want an array of strings. Each one of those things takes a different amount of memory. An integer array would take 4 bytes for each entry. A double array would take 8 bytes for each entry. How can the Java virtual machine create this if it doesn't know how much memory you're going to require for it? That's why in C, when you call malloc, you don't say, malloc, give me 50 integers. You say, give me X bytes. And whatever you do with those bytes, that's your business. Right? A similar problem here. The Java virtual machine needs to allocate memory somewhere, and it needs to allocate the exact amount of memory. So we can't do this. Instead, what we can do is an object array. Right? Oh, come on. You should be able to do that. Yeah, oh, okay, yes, it is able to do this. Don't worry about this for now. So let me go ahead and change this to show you that this actually works. Object array foo is equal to this. It's happy about this. You can create an array of objects. Well, all objects are just references. All references only require 32 bits, 4 bytes. Or maybe it's 8 bits. 8 bytes, I don't remember. Who cares, right? It was complaining originally about this because the thing on the left-hand side is an array of t's. The thing on the right-hand side is not an array of t's, it's an array of objects. Right? So what we're going to have to do is an explicit typecast of this thing. Right? We're going to have to do something very similar down here to increase copy. Oh, actually, no, we won't, because I believe that this is parameter. Yeah, see, this is parameterized. Right? The version that we were calling before was only for ints, small I integers. This one is parameterized, so it's taking care of it for us. Right? Nice, 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 until we get down here. Uh-oh. What is x? X is an integer. We can change that. We're just making this generic. We're not taking integers anymore. We are taking elements of type t. That fixed it. Add to end. We're not taking integers anymore. we're taking elements of type D. What about get element at index? Well, it's still going to be at that index, but it's an element of type T, not an integer. I only changed like 3 or 4 things to make this completely generic, right? And now I've got a solution that will work for anything. Over here in my demonstration, I can go ahead and integer parameterize this, and it will work exactly as before. I can now parameterize this, and it'll also work with strings. There. And everybody is happy, right? I only had to write one list implementation to rule them all, right? Strings, integers, doubles, whatever you want, whatever user-defined type, bank accounts, items, right? It's all taken care of now. In fact, this is looking very similar to what's actually implemented in the array list class, right? I've basically reinvented the wheel here. You would not do this in practice. You would do this on your last assignment, something similar to this on your last assignment, but you would, in practice, you would never invent your own list, right? You just use what's built into the language. Right? I did this to show you how the list is built, how it's implemented, and how it's designed as well. Because again, we're using good object-oriented programming principles here. Now we do have encapsulation, the protection of our data and representation. We've got abstraction. You don't worry about those details. I take care of it for you. And we've got polymorphism. It applies to any type of variables that you want to store. Okay? All right. Thoughts on this so far? No? Do we want to do anything else with it? We could get really fancy, right? We could have other types of other functionality, right? We could have sugar on top of that, other functionality, right? A way to clear out the list, right? A way to shrink the list if its capacity is too much. In other words, it's being wasted. Right? A way to add multiple elements, right? A batch add. A way to, what else would you want in your list? A way to, say, copy one list to another, right? A copy constructor. Right? Nice. What else could we do? Oh, okay. A find a particular element, right? That is search. And what kind of algorithm would we use? Probably a linear search algorithm, right? Maybe with a comparator or something like that. The first element, the second element, the last element that matches whatever criteria you want, right? What else? If we have insert at the beginning, or if we have insert at end, maybe we want an analog. Insert at the beginning, right? What would that look like? That one's really easy. We've got add to end. What if we want add to start? Copy paste, except that there might be stuff in there, right? We would have to shift things down. We probably don't want to use that code. What code do we want to use? Add an index 0. So copy paste, or this dot add at index 0, or x at 0. Right? Code reuse. In fact, wait, I can do the same thing here. This dot add at index what? This dot size. Awesome. Right? Anytime you can cut down code means that you've got fewer and fewer failure points, potential failure points. I really only have to ensure that this method is correct. I really only have to test this method because those two other methods rely on it. Right? As long as I have high assurance that this method is correct, I also, transitively, I have high assurance that those other two methods are correct. And I don't know if they are. Let's go ahead and find out. What happened? Index 10, out of balance for length 10. Add at index. Regression testing. You changed something. I refactored it to make it a little bit better, right? Less brittle. But in the act of doing that, I broke it. What happened? At an index over here, it says, okay, well, those are perfectly fine, right? If this size, that capacity, whatever, you know what? No, now I'm not convinced that I actually broke it. What was wrong? Demo 8, what were we adding? Okay. Add to end. If the index is, oh, there. The index is greater than size. Say what? It was size, exactly. I added the 10th element at index 10. I should be able to do that, right? That's just adding it to the end. Right? So if it's, if it's greater than size plus 1. That should be right, right? Let's take it 0, 1, 2, 3, 4. You want to add it to 5. If index is greater than, oh, that should be right. This one? Yeah. I'm kind of baffled about that too. So, excellent opportunity here to show you something that I think I've showed it before. But let's go ahead and go into a debugger. So normally you can add a breakpoint at a particular location. I don't want to have to cycle through that 10 times to get to when this is index 10. So what I'm going to do is I'm going to go ahead and, well, here, go into debug mode here, stop the debugger, and I'm going to add a breakpoint in here. What kind of, first of all, what kind of illegal argument exception, all right? So I've got a bunch here already. Let me go ahead and get rid of these. Don't worry about these. Don't worry about these. All right. I can add. Come on. Remove them all. Let's simplify this. Let's see. Show breakpoints. Oh, here we go. This is it. The Java J and then the exclamation point. That's add Java exception breakpoint. I had to remind myself how to do this. So illegal argument exception. You can search through this for, say, null pointer exceptions or whatever. You want to stop the program at the point where that exception occurs so that you can look at stuff. Normally, if that exception occurs, the program just dies. I want to go ahead and stop it if we ever see an illegal argument exception. So let's go ahead and play this. All right, there we go. And there, it stopped. Right? An illegal argument exception occurred, and now I can come over here and look at my variables. X that we're trying to insert is 100. The index is 9. Does that make sense? Yeah. And index I is 1. But this array, the size is 9, so we're good, right? 9, 9, that's fine. But array is what? It's not full yet, but that null, I'm trying to shift that over, basically, right? And when and there are 10 elements in there, so the maximum index is at 9. So when I try to shift this null over to index 10, that's beyond the capacity there. And we never increase the capacity. The capacity here is still 10, right? So what is our, what should have been our condition for increasing the capacity? Since we're shifting stuff down, we want to make sure that there's still, room. So if this dot size is, let's see, the size would be 9, and your length would be 10. So if the size is less than, or before it was equal. I'm getting myself confused here now too. Less than, no, greater than -1. Or we could just go back to equals here, right? One less, right? There, that's the easier way of thinking about it. The capacity is 10. Now we're saying, what if the capacity is only 9? Then we can't shift things over. So increase the capacity in that case. And when I do that, there, it works again. Right? And I don't get that illegal argument exception over here. But I do, I'm glad that happened because I had the opportunity to show you conditional breakpoints. Here's another one. Let me go back over here to demo. And let me go ahead and add this breakpoint back in. And we'll make it conditional. Conditional, you see this little, I can't increase the size here, but there's a conditional checkbox right here. Suspend when true, and I can write any condition here that I want. If I is equal to 100. So in other words, on the last iteration, or maybe somewhere in the middle, if it's equal to 50, right? And I think it's automatic. Yeah, it's automatically saved. So if I debug this, it stops, and you'll see over here that I is indeed 50. It stopped when I wanted it to. You can put any Java condition that evaluates to true or false in there. And it looked to me like you could also suspend when true, suspend when the value changes. Right? Just I think would do it. There we go. So that's kind of in GDBC. Remember, we use the watch I. Anytime I changes, stop and let me look. Right? And so we can do that. I think that's what this will do. Maybe not. Maybe that's not a watch variable or not. Let's go back over here to the variables. 10. It changed. It went from. It was initialized. Okay. Let's go ahead and continue up here. It stopped when it was 20. Stopped when it was 30. Stopped when it was 40. Right? Oh, okay. Now 40 something was going on there. I need to look at that. So let's go ahead and jump into the add to end method here. Oops, that jumps over. Right? Let's go ahead and continue when it's 50. There we go. Jump into is this one up here. Step into, this is step over. Step into actually goes into my class here. Actually, it's going into the integer class. All right, I don't care about that. Blah, 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 blah. All right, step into that. There we go. And we see, oh, okay, add to index. Add to end calls add to index. So let's step into that. Right? Okay. Step over. The capacity was not increased because, of course, it's 10, and we're only inserting the 6th element. There's plenty of room. Okay, and we shift elements down here. So if I want to take a look at this array, I can see this in action as I step over this. Oh, sorry, it was adding to the end. I was hoping to see stuff get shifted down, but it wasn't. You just see here that it was added at the end. Right? So use your debugger to its fullest if you have not been already. You have conditional breakpoints. You have exception breakpoints. Right? And then always go back to your Java perspective when you're done. Insert at the beginning, find a particular element, copy one to another, right? Anything else we want to do in the last 5 or 10 minutes here? That's easy. How about clearing out the list? Public void remove all. Or remove all elements. You have 10 elements in there. Removing them all means that you now have what? 0. All you need to do is set that to 0. Now, the old elements are still in there. Who cares, right? That encapsulation means that I'm the list. I don't care about it. They might care about it, but I don't care about it as long as I set the size to 0. From their perspective, it's an empty list now, right? I could go through and like reset them all to 0. That wouldn't get me anything. I could throw away that array and create a brand new array with capacity 10, like I did up here, right? That doesn't really buy me anything either, but I could do that. Right? In fact, copy. Maybe I should put that into an initialization function because it's the same thing. Right? Okay, so we will continue with this next week, and unfortunately hopefully the recording worked. I don't know how much was actually preserved online.